Hello, everyone, and thank you for joining in on our Introduction to Energy Efficiency and Conservation webinar. My name is Eric Bensala. I am an Energy Advisor for OPPD. If you have any questions by the end of this webinar or would like to learn more, please feel free to send me an email or leave me a voicemail. In this webinar, we'll get a crash course in all things energy efficiency. Some of the topics in today's webinar have their own webinars already, so we won't spend a lot of time on them. Let's get into it. When it comes to defining energy efficiency and conservation, we need to make a clear distinction between the two terms. They are often used interchangeably, but in fact have very different definitions. Energy conservation is the reduction of energy at all costs, regardless of comfort. Energy efficiency is the reduction of energy without a loss of comfort, sort of like the aphorism, work smarter, not harder. In other words, conservation comes from the behavior or thing you do, no matter what, that will save energy, but may not be the most comfortable. Efficiency is using something, specifically a technology, to reduce your energy without being uncomfortable. Let's look at an example. Turning off your lights is an example of energy conservation. During the day, you can still use sunlight to see and light up your home, but at night, of course, it's dark. There is a loss of comfort there, but you've reduced your electrical energy consumption to zero. Using an LED light bulb instead of an incandescent bulb or even a CFL bulb is an example of being energy efficient instead of energy conserving by turning your lights off. You would like to maintain the comfort of being able to see at night, so being efficient would be using an energy-efficient light bulb, which is considered a technology. You'll use less energy than the other types of bulbs, but still have the comfort of lighting. To expound on this a little more, on the left we have the use of technology to help us reduce our energy usage, otherwise known as being energy efficient. On the right, we have our more behavior-oriented method to reduce energy usage, which we call energy conservation. In the middle is what I like to call being energy conscious. Being energy conscious is using both methods, efficiency and conservation, to achieve a reduction in energy usage, which reduces your energy bill, and a reduction in your carbon footprint. Now that we have a little bit of vocabulary for the rest of the webinar, let's dive into insulation. The main function of insulation is to slow the flow of heat from one area to another. It is not meant as an air sealing solution, except in the case of spray foam insulation. As with all energy efficiency measures, insulation has its own measurement of effectiveness. We call this R value. Reading and understanding R value is pretty straightforward. The higher the R value, the more effective the insulation is at the reduction of thermal energy transfer. In other words, the higher the R value, the better the insulation is at slowing the flow of heat. The map on the left shows the different climate zones in the U.S. OPPD's service territory is in that green zone, Zone 5. Using the table over to the right, we can see that in an uninsulated attic, we'll need about R49 to R60 of insulation. But if your attic has 3 to 4 inches of existing insulation, we should add roughly R38 to R49. And the floor joists, the recommendation is anywhere between R25 and R30. There are about 5 different types of insulation. From left to right, we have blanket bats or rolls of insulation, spray foam, blown in, foam board, and a reflective or radiant barrier. Bat insulation is one of the more common types you'll see and are fairly inexpensive. These are generally found in wall cavities or in between ceiling joists for a floor just above an unfinished part of the home. With bat insulation, do not force it to fit. If you need space for certain things like outlet boxes or plumbing, cut the bat away from those objects. If bat insulation is compressed, it loses its R value and ability to work effectively. Spray foam is really great for sealing leaks and gaps, as it can get into smaller crevices bat insulation cannot, and then expands into a solid. This makes it a pretty permanent solution, though. It is best to leave the installation of spray foam up to a professional. Blown-in insulation is just that. It's loose fill insulation that is blown into cavities, particularly between joists in an attic. This can be a do-it-yourself type of situation, or you can hire this out. Foam board is a very common form of insulation, especially with new construction. Foam board is good for foundation or basement walls, floors, and ceilings. Its popularity is due in part to it being one of the most efficient forms of insulation at reducing energy loss. Lastly, we have the reflective or radiant barrier. You will find these generally in consistently hot climates in the attic. They reflect heat away from the home to prevent heat gain or heat transfer to the cooler surfaces. With all of that insulation, we have to know where to put it. Now, this list is not extensive, but shows more of the common areas and applications. Attics are a common area for insulation, as we all know. Loose fill, blown-in insulation is the best application here. With exterior wall cavities, we generally find batt insulation, but due to their permanent nature, spray foam and blown-in works well too. The main thing with batt insulation is to cut out space for electrical boxes, plumbing, and the likes. Do not pack batt insulation in. Floors above cold spaces, again, batt insulation is best here, especially without the backing to help reduce the possibility of trapping moisture. You can secure the batt using wooden cross beams or something similar to hold it in place. Band joists or rim joists, yet again, another application for batt insulation cut to size. You can also use spray foam, or even easier is foam board. If you use foam board, you can also seal the edges to help prevent air leakage, though it is not required to do so. Crawl spaces, which we have a bit of in this part of Nebraska, though not in newer construction generally, are best insulated using batt insulation, again, without the backing to avoid creating a moisture barrier that could lead to mold. To close things out with insulation, let's take a brief look at some of the other forms of insulation that are out there. Heavy curtains, or just curtains in general, provide some form of insulation. We have all heard the energy efficiency tip about closing blinds or curtains to direct sunlight. This does have an effect on the temperature of a room, increasing or decreasing depending on the time of year, the direction the windows face, especially if it's south, and the material your floors are made of. Outlet gaskets do provide a small bit of insulation for your exterior wall-oriented outlets. Anytime you have a hole in your exterior wall, even when it's the interior portion, that is a space for air to infiltrate or escape. Gaskets, which mount on the back of the outlet plate, can help alleviate that infiltration, and they do come in a variety of shapes depending on your outlet or switch. Another really great and simple insulation measurement to consider is insulating your cold and hot water pipes. Insulating those pipes can help keep cold water cold and hot water hot without losing heat or gaining heat from ambient air temperatures in unfinished areas, or if the pipes are too close to one another. Weather stripping is more of an air sealant than an insulator, but it still fits in the realm of what we're talking about in this section. It's always recommended to try weather stripping on doors and windows before replacing them. Not to mention checking on any existing weather stripping to ensure it isn't cracked, falling apart, or missing. Lastly, we have a pretty unconventional form of insulation, bubble wrap. Foil-faced bubble wrap only has an R value of about 1 or maybe just a touch over 1, but it still can provide a little bit of insulation or help with it, especially in the summertime for south-facing windows. For a deeper dive into insulation, please check out our webinar on insulation. Let's transition into HVAC, or heating, ventilation, and air conditioning. First things first is that filter. Your heating and cooling system has a filter the air passes through. While it is called a furnace filter, it is also used when your air conditioner is running. Basically, if your blower is running, the filter is being used. There are a handful of things to know about your filter. 1. Check or replace it monthly. You won't really know how dirty it is until you look at it. You can still get decent airflow with a dirty filter, but you will have poor air quality. Pleated filters are best for air quality versus your traditional cheap fiberglass filter. 3. When getting a pleated filter, be cautious of getting a filter that is too good for your system. Most HVAC systems do just fine with a MERV rating of 8 or 11. MERV stands for Minimum Efficiency Reporting Value. It is a measurement scale of how well the filter filters out various particles. The higher the MERV, the more that is filtered out. But again, that can lead to problems with your system, especially with a 1-inch filter and a really high MERV rating. Lastly, number 4, and in reference to the second item, the filter's first and primary job is to protect the internal components of your furnace and A-coil from damage caused by a buildup of particles in the air as they're sent through your central heating and cooling system. The second job is to help filter the air. Additionally, the reason it's important to at least check your filter once a month, especially from an air quality perspective, is you don't really know what it looks like without looking at it. Now, years ago, I moved into a home that had the bathroom tiled and redone. What I didn't know at the time was they did not cover any of the return registers nor partition off the bathroom while this was being done. If you've ever seen tile work done, especially the cutting of it, it creates a tremendous amount of dust. This dust was filtered through the home and into the HVAC system, which eventually clogged up the furnace filter, but still allowed some air to pass through it. When I had dusted the entire home and found it still became dusty right away, I got concerned and checked the filter, and sure enough, this is what it looked like. I still had airflow, but was breathing in tile dust, among other things, for a few days. The return and supply registers in your home are like the mouths of your HVAC system, breathing air in and exhaling air out. The main thing to keep in mind with your registers is to keep them clear of any obstructions, particularly with the return registers, which often get forgotten or assumed have no real value since you cannot feel the air passing into them too much. However, with return air registers, especially newer ones with the smaller inlets like the far right image, these can become great places for dust and pet hair to accumulate. So, once a year, it is a good idea to give them a good vacuuming using the brush attachment, especially if you're able to take the register off from the wall. If registers are the mouth of the HVAC system, the ductwork are like the airways. On the far left, you'll see a return air duct that uses the space between the floor joists as a duct with what's called duct board inside of it. The middle and right image are supply ducts. Something to look for on your ductwork are these little levers or even just a wing nut. These control dampers inside the duct that close off airflow to certain takeoffs that go to various rooms. Closing or opening these dampers can help balance the airflow out in a house far better than opening or closing registers. The reason being, these dampers are placed much closer to the source of air, in other words, closer to the furnace setup, allowing more air pressure into the other takeoffs, creating better airflow. Unfortunately, there are many homes that do not have these, so don't be surprised if you don't. At that point, using the register is the only option. Be sure to watch our webinar on airflow for more information. In Nebraska, most of our homes use natural gas for heating, but some furnaces are resistant or electric furnaces. When it comes to gas heat, there are a few things to keep in mind. Furnaces generally come in what is called 80 or 90% efficiency. The furnace on the left with the metal flue pipe is an 80% efficient furnace, whereas the furnace on the far right is a 90% efficient furnace. These numbers are not exact, but rather markers for roughly how efficient they are at the energy conversion process. In the case of the 90%er, you'll notice it has two pipes coming out of it, one to bring in fresh air from the outside, and the other is the flue pipe for the gases produced from heating. That fresh air intake helps make that furnace more efficient. Additionally, for both types, the flames for your gas furnace should be predominantly blue. And lastly, as far as energy usage goes, for a gas furnace, the blower generally uses about 400 watts, but with a resistance furnace, you're looking at upwards of over 20,000 watts for the entire operation, not just the blower. Which brings me to an important distinction when it comes to the term energy efficiency and energy usage. Energy efficient does not automatically mean cheaper. Given the cost of natural gas and the cost of electricity, and then the energy required by a gas furnace to heat a home versus the energy required for an electric resistance furnace to heat a home, It is still more expensive to heat a home with an electric resistance furnace, despite it being 100% efficient, and a gas furnace being anywhere from 80 to over 90% efficient, at least as of 2023. Looking at the diagram here, when we talk about a furnace, heat pump, or air conditioner being energy efficient, it is talking about its ability to convert electrical energy into thermal energy. An electric furnace or heat pump, which uses electricity, has no loss in that conversion. A gas furnace has to burn something, and anytime we burn something to create thermal energy, we have losses, which is why a gas furnace cannot be 100% efficient. Jumping back into HVAC here, air conditioners come in two main types here in the Midwest. You have your central air conditioner that has an A coil inside the home, above the furnace components, and an outside condenser unit as you see in the bottom right. As a note, heat pumps generally look the same on the outside, though you will likely and hopefully see them propped up off the ground to allow for air to come in from underneath. There is also window air conditioners, as you can see in the upper left. Window air conditioners tend to be pretty inefficient when compared with a central air unit, but if you don't have a central air conditioning, it's the best alternative. In some situations, homes will have both a window air conditioner and a central unit. This generally means there is an airflow problem of some sort which could be corrected, but in some cases, it could also allude to an older, inefficient central system unable to accommodate the entire home. Central air conditioner units' efficiency is known as SEER, or Seasonal Energy Efficiency Ratio. The higher the SEER, the more efficient the unit. Now we are going to move into all the other nooks and crannies of the energy efficiency world. The thermostat is there to control your HVAC system, which enables you to make yourself comfortable. With that being said, particularly when it comes to the comfort and energy efficiency, we do not have a degree recommendation to set your thermostat to. The reason being is every home and system, the occupants in the home, and more, are so different from one another that giving a recommended temperature setting would only really complicate the matter. In other words, 72 degrees in one house will not feel like 72 degrees in another house when it comes to comfort, nor will 72 degrees in one house cost the same as 72 degrees in another house. There are too many variables to know with any certainty that the same temperature from one house to another would have the same comfort and energy usage effects. With all that being said, each degree you change your thermostat can either increase or decrease your usage by as little as 1% or as much as 5% per degree. That's depending on your system. And that fan setting, generally just leave it on auto. Setting it to on can help circulate air, especially in the summer when the basement is much cooler, but don't leave it on for too long as it can also increase the humidity of the home. Upgrading your light bulbs is one of the easiest ways to be energy efficient, reduce your electricity usage, and thus your electricity bill. The easiest way to look at it is through this comparison here. Incandescent bulbs generally come in the 60-watt variety. Out of the 100% of energy used by an incandescent bulb, only 10% of it is light. The remaining 90% of it is heat. This is why they are considered very inefficient. The light is from the hot, glowing filament inside of the glass bulb. It gets so hot that it glows, producing light. By comparison, an LED is just about the opposite. 90% of the energy it uses is light, and 10% is heat generated by the components inside. From a cost perspective, if you were to use a 60-watt bulb for 10 hours a day, it would cost you roughly $1.83 a month. If you were to replace that bulb with an equivalent 9-watt LED bulb 10 hours a day, it would cost you only 34 cents a month. That's a significant amount of savings for just one bulb. So what then is the payback period? The payback period for an energy efficient measure, whether that is from a big project like replacing your HVAC system to as small as just one light bulb replacement, is the amount of time it takes for the energy efficient upgrade to pay for itself via the reduced energy usage and thus reduced cost. Using our light bulb comparison, an equivalent LED bulb of 9 watts, replacing a 60-watt incandescent bulb, will pay for itself in about 4 months. You can buy a 9-watt LED bulb for $5, often much less, but we'll use that for our equation here. We'll take that upgrade cost, $5, and divide it by what we stand to save every year in our box in the upper left corner, and we get about 0.28 years, or roughly 4 months, meaning after 4 months, the LED has paid for itself with the savings alone, and now you have a cheaper bulb to operate, not to mention one that will last much longer than your typical incandescent bulb. Moving on to fans, ceiling fans spin 2 directions, either clockwise or counterclockwise. These directions serve 2 different functions. Counterclockwise is the most common and helps provide air movement in a room, which helps create the wind chill effect, making you feel cooler. It should be noted, however, that in most cases, a ceiling fan will slightly increase the temperature of a room by a few degrees, so don't leave it on in the summertime if you aren't in that room. On most models, there is a button on the hub that you can push or move that will cause the fan to spin clockwise. This helps circulate warm air up and out to the walls of the room without providing too much of the wind chill effect. When the heat is on, you can turn your ceiling fan on low, spinning clockwise. It can help to even out a room's temperature, especially with uninsulated walls. Box or directional fans serve the main purpose of the wind chill effect, but in some cases can help distribute air-conditioned air from vents placed in parts of a room that make airflow difficult to even out. It really depends on the setup of your room and where the registers are at, but in some cases, these fans can help pull that cold air out and through the room a bit better. Space heaters can be great for supplemental heating. They can be energy savers when used properly, such as in a smaller room with the thermostat turned down. So instead of heating up the entire home to the warmth you need in that one room, assuming it's just you in the home, you can use a space heater on low to achieve that without turning the thermostat up. Electric space heaters tend to be the safest, especially in small rooms, as they will not deplete the oxygen in a room. Whatever space heater you use, however, never leave them on unattended. From a cost perspective, as an extreme example, if a space heater is used 12 hours a day on high, this can cost you over $50 a month, so use them only when you need to. It might be just as well to put on slippers or even a sweater. Alright, now on to one of the most popular energy efficiency tips you'll hear or read about, phantom load, or energy vampires. The idea behind phantom load is that even if an electronic device, whether that's an appliance, cell phone, TV, etc., is plugged in but not turned on or being used, it will still draw electricity. So the tip goes that you should unplug those things to save electricity and save money. This tip was put to the test in one of our videos, which you can find on YouTube, but to answer whether this tip is true or not, the answer is mostly false but somewhat true. Using a watt detector, I tested and measured the phantom load for a few items, starting with a cell phone charger. First, I found out how much electricity it consumed while plugged in, but not in use. I tested it over the course of 16 hours, but multiplied that result by 30 for a month. So, unplugging it after each use would only save me about 2 cents a month. I'm not one to say whether a certain amount is more valuable than another, but 2 cents a month for savings isn't enough for me to unplug my charger in between. Going bigger, I tested my workstation. 2 monitors, all plugged into a docking station, which require power. Same test, assuming 8 hours of use a day, but not in use for 16 hours and still plugged in. If I were to unplug this system after every day I worked and left it unplugged for 16 hours, I would save roughly 45 cents a month. Same test with my entertainment center. 42-inch TV, sound system, 2 video game systems, unplugged 16 hours a day, saves about 90 cents a month. Long story short, it does reduce energy by a tiny amount, but the effort may not be worth the savings. Simply turning things off yields savings that an additional unplugging just simply adds more work than savings. However, there is a technology that could make this unplugging situation a lot easier. Smart plugs and smart outlets can help you eliminate phantom load or drastically reduce it without the hassle of having to bend down and unplug things or plug them back in. Other smart technology items include smart light bulbs, power strips, thermostats, and more. All of these can be controlled either by an app on your phone or through Alexa and Google Home. For more information and a much deeper breakdown of these technologies and more, check out our webinar on energy efficiency and smart technology. All right, let's touch on health and safety before we close things out here. One of the main concerns when it comes to the health and safety of our homes is carbon monoxide levels. This really only applies to combustion type items like a gas water heater or furnace. If you have an electric resistance furnace and electric water heater, carbon monoxide is not a concern from these appliances. Carbon monoxide leaking out into your home in lower concentrations, about 5 to 50 parts per million, can create flu-like symptoms and at times will go unnoticed, especially during flu season. But in higher concentrations, 50 to 3,000 parts per million, symptoms include severe headaches, vomiting, and could result in death. The EPA's, that's the Environmental Protection Agency, maximum exposure in an 8-hour period is 9 parts per million. So how does this happen? How does carbon monoxide leak into the home? It can happen from combustion appliances like gas furnaces or water heaters, functioning improperly, or if there is too much negative pressure in the home. This negative pressure can lead to backdrafting, where the flue pipes that use the stack effect to vent these gases can no longer do so, leading the carbon monoxide to leak out into the home. One of the best ways to safeguard you and your family from the effects of carbon monoxide poisoning is to have a carbon monoxide detector that can plug in near your furnace and other living spaces, especially the bedroom, with a battery backup. While these do not show you a readout of the current levels, they will alert you if it becomes too high for your health, meaning you should evacuate your home and call 911. If you don't have a plug near your furnace, at a minimum, these should be in living spaces or in areas you frequent and sleep in. If you want to take it a step further, you can always purchase air quality monitors from your local home improvement store or online. They run anywhere from $50 to $150, and many come with an app for your phone. These will tell you the actual levels of the home for carbon monoxide, humidity, and others depending on the model. For a deeper dive into health and safety, please check out our webinar on health and safety. To close out this webinar, let's look at some of the resources OPPD currently has. We have a whole slew of tips, videos, do-it-yourself items, and more on our energy efficiency web pages at oppd.com/EE. You can also navigate there from our website at oppd.com by hovering over the residential drop-down menu, then going down to energy efficiency. Also on our website, we have more information about our products and services, from residential surge guard and the electrical line plan to our Cool Smart and thermostat programs, as well as some rebates. You can find out more at oppd.com under the residential dropdown and then products and services. That concludes our introductory webinar on energy efficiency and conservation. Thank you for watching and have a wonderful day.